So we're going to be looking at 5.3 here. And first thing we're going to look at is we're going to be factoring binomials. So we need a table of squares. So we need a table of squares. So we're going to go all the way up to 12 squared. So we'll start with 1. And we know that 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is going to be that 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared, of course, is 100. 11 squared is, I believe, 121. We don't use it that often, so let me check. Yep, it is 121. And 12 squared is 144. Okay, so these are our squares. When we look at factoring these binomials, we're going to primarily be focusing on differences of squares. There are cubes as well. We have a little bit of time at the end. We may look at some cubes, but cubes are not as important as squares. Sometimes you do have to factor as a difference of squares in college algebra. So we need to make sure that we know how to factor these down. This also works for what are called perfect square trinomials. Here's our formula for a difference of squares. So the difference of squares formula is this: x squared minus y squared equals x plus y, x minus y. All we're going to have to do is see what squares we have and then make them fit into this formula. So it's very, very easy. So let's start off with a few of these. How about we have 9x squared minus 64. So now we count the number of terms, and so this has 2 terms. So we're going to factor this as, in this case, a difference of squares. And so we look at our table of squares up here, and we notice that 9 is what? 3 squared, right? What about 64? Well, 64 matches up to the 8. So when we go to factor this, what I usually do is I write it over to the side. 9x squared, I can split that up into 3x and 3x because we split the variable in half as well. And 64 is 8 times 8. So this will come down as we have a plus and we have a minus. It doesn't matter which one goes first. I usually write the plus first, but either way. And what I do is we split it up here. So that's 3x, 3x, and then 8 and 8. And that is your your difference of squares. Okay, so that's going to be your difference of squares there. Let's look at some more of these. How about we do 121x to the 10th minus about 4y to the 8th. So let's see how we would factor this one down. Well, what do we know about 121? We look back up here, right? 121 is a perfect square of what? At 11. Now, when we come to our exponents, we split them in half. So 121x to the 10th, C, would split up into 11x to the 5th, and 11x to the 5th. Because we take our exponent, our power of 10, and we split it up into 5 and the 5. And then 121 is a perfect square of 11. Then we have our 4, y to the 8th, and 4 is a perfect square of 2, 2. Y to the 8th would make it y to the 4th. And y to the 4th. And then what's our answer going to be? Well, we have a difference of squares, so that's a plus and that's a minus. And then we have 11 x to the 5th, 11 x to the 5th, and then we have a 2 y to the 4th, and a 2 y to the 4th. And that's it. Now, in some cases, you may have to factor something out first before it'll factor. So there might be a variable that has to come out, or a number, or both that need to come out. So how about we try to factor 5x cubed minus 405 x z to the 4th. Right, so on this one, when we look at this, and these are all factoring here, when we look at this, 5 is not a perfect square at all, is it? Now when we look at these, we need to see, can we take something out of here? Yeah, these are both multiples of 5. So we're going to take a 5 out, and they also have a variable x in common. So a 5 and an x comes out. That is then going to leave you with an x squared minus, and what about that 405? Okay, it has a 5 in it, so 405 divided by 5 gives you then what? 405 divided by 5 is then that 81. So that's going to be 81 z to the 4th, because the x came out, didn't it? Now we know what to do, because now we can clearly see that 81 is a perfect square. So differences of squares are very easy to do. 81 is a perfect square. We know that that x squared, well, that x squared is x and x, right? And we know 81 z to the 4th is going to be 9z squared and 9z squared. We'll put these together. And we have a 5x here. And what do we have left? We have an x and an x, because that's your x squared split up. And we have a 9z squared and a 9z squared there. That's as far as you can go there. In some cases, you may have to factor it multiple times. So there are some cases where you've got to factor and then factor again. So here's one where you're going to have to factor twice. Okay, so it's pretty easy to factor because, again, we know 16 is a perfect square of 4. And x to the 4th, we split the exponents in half. And so that's x squared and x squared. And then 16 is 4 and 4. So plus and minus. We've got x squared and x squared. And then we have a 4 and we have a 4. Now, we are not completely done yet, and why not? Okay. This one cannot go any further. Why can this one not go any further? Well, it can't go any further because it's a plus. When we look at squares, we are looking at a difference of squares. So it has to have a subtraction symbol in between them. This one has a plus. This is a sum of squares, so it won't go any further. However, x squared minus 4 will, because 4 is a perfect square of 2. So it will go one step further. So the x squared plus 4 stays the same, but the x squared minus 4, well, that splits up into x and x, plus and minus, 2 and 2. And that's as far as you can go. Why can we not break this one down? Because this one has a plus. Let's do another one. Let's do one that has a quantity squared. We have about 49 y to the 8th minus 2 plus a quantity squared. Now, when we go to factor these and we talk about squares, it doesn't matter if it's a variable squared or if it's an entire grouping squared. It's going to be treated the same. Well, the first piece is 49 y to the 8th. And we know that 49 is a perfect square of 7 and 7. And y to the 8th is y to the 4th and y to the 4th. We have a plus and we have a minus. And what about the 2 plus a quantity squared? Well, 2 plus a quantity squared is the same as 2 plus a and 2 plus a, right? It's the same. So how is this going to work? Well, we need a 7 y to the 4th, 7 y to the 4th. What goes here and here are 2 plus a here, and this one, be careful, use parentheses, because with subtraction, we have to distribute that negative through. So that's 2 plus a here. The first one is fine, because the plus is okay. But what about the minus? We have to distribute it through. And what does that leave you with when we write it all out? We have 7 y to the 4th plus 2 plus a, and we have 7 y to the 4th minus 2 minus a. And that's it. That's as far as we can go there. Let's do another one. Let's do one that we've got to factor out and then factor by grouping again. So how about we look at, let's say, we'll just do, how about 27 z cubed times a minus 3b, quantity squared, minus, how about we use 3z times a minus 9b, quantity squared. Okay, so this one, it kind of combines everything that we've learned so far. It's still pretty easy to do, though. So the first thing I would do is I would look and I would see, are my groupings the same? No, one's a minus 3b, one is a minus 9b. What do we know about the 27 and the 3? Well, they have a 3 in common, and they also have that variable z in common. So I'm going to take out a 3z. And that leaves me then with 27 divided by 3 is a 9, z squared, a minus 3b squared. Okay, and then we have a minus, so that all comes out. A minus 9b quantity squared, right? We have extra parentheses. We can use square brackets if we need to also. But what we really need to do is just keep this 3z out front. It's just going to drop down and come along with it, so we don't really have to worry about it. It just stays there. Now, what do we know about this here? Well, if we go over to the side and work with it, we work with 9z squared times a minus 3b quantity squared. Well, that can be rewritten as 3z times a minus 3b and 3z times a minus 3b. Because those are the same, aren't they? Just wrote it out because that's a square. So 9 is a perfect square of 3 and 3. Z and z, and that splits up there as well. And we know this is a square here, so it can also be split up. So let's leave ourselves plenty of room. And let's see what we've got. So we have a plus, and we have a minus over here. So we've got 3z and 3z, and we have a minus 3b, a minus 3b here for this piece. And then for the next one, for the end over here, we have a minus 9b. And use parentheses on this one, a minus 9b here. It becomes a little bit tight on space there, but that's what we've got. Now, let's try to break this up and combine it and condense it down. So all the factoring is done. All we need to do now is distribute, combine like terms, and clean it up a bit. I'm going to start by pushing through the 3z. So that's going to leave me then with 3za minus 9zb plus a minus 9b. So that piece is done there. Nothing can be combined together, can it? Right? We can't really factor and we can't really do anything with this that'll be meaningful. Nothing can, we could try to factor by grouping, but nothing to really group together correctly because this has that a there. And then you can try it, but it won't factor out correctly. What about over here? Well, same thing. We're going to distribute that 3z through. And we're also going to have to distribute that negative through. So let's see what we have here. What we have over here is we've got 3z, a, minus 3 times 3 is 9, zb. And we have a minus a, negative and negative makes it a positive 9b. And that is as far as we can possibly go. So we factored out that 3z, so it came down. We factored it again as a difference of squares. Most of the time, they'll be a little bit easier than that one, but you may encounter something like that. Let's do a couple more of these just to make sure we completely understand how to break these down. Then we'll look at some that do not factor, and we'll talk about why they do not factor. So let's do a couple more where they factor. This one's going to have lots of variables. Used x's, we'll use an x here. How about x to the, let's say, 20th power. Now, when we go to factor these, the first thing we need to look at is we look at our numbers. 100 and an 81. Nothing's in common, but 100 is a perfect square of 10, and 81 is a perfect square of 9. So we're okay there. Now, when we talk about these variables, we look and we make sure that no variables are in common. They're all different. And when we talk about these variables, for it to be factored as a difference of squares, these variables, the powers, need to all be even because we have to split them in half. We can split 10 in half, 4 and 8 can all be split in half. This 4 over here, the 12 and the 20 can all be split in half. So that's the main thing we look at is we look at the powers and we make sure that they can be split in half. And we know we have all these squares to work with. And so let's work with our first one. We have 100, a to the 10th, b to the 4th, z to the 8th. Well, what is that going to factor into? We know that 100 is a perfect square of 10 and 10. A to the 10th, we'll split that up into a to the 5th. A to the 5th. B to the 4th is b squared and b squared. And z to the 4th and z to the 4th is over here. Okay, we just split them in half. So that is going to then come out to be 10 a to the 5th, b squared, z to the 4th, 10 a to the 5th, b squared, z to the 4th over here. What about 81, p to the 4th, m to the 12th, x to the 20th? Well, 81 again is a perfect square of 9. So that's 9 and 9. P squared and p squared. See, we're just halving. Half of 4 is 2, so that splits up. M to the 12th. 12 goes up, it splits in half into 6 and 6. And x to the 20th is 10 and 10. Okay, one's positive, one's negative. And we need a 9 and a 9. We need a p squared and a p squared. We need an m to the 6th, m to the 6th. And we need an x to the 10th, x to the 10th. So we're okay with that so far. You just got to be very careful with the exponents here. They all have to split in half. Now, these have all been factorable. Now, let's look at something that is prime, that is not factorable. Let's look at something that is not factorable here. And let's see why these are not factorable. Why is this one not going to be factorable? How about x cubed minus 9 z squared? Why is this one not factorable? If I want to factor it, what do we know? If I want to factor this, we have to be able to take our exponents and divide by what? 2. Well, x cubed cannot be split up that way. It's not a difference of squares because x cubed can't be split in half. So that's why this one is prime. So the reason why this one is prime is it must be even. So this one is what's called prime. This one is also not factorable here. 5x to the 20th power minus 9z squared. Why is this one also not prime? Well, for it to be again factorable, what must happen? We must have perfect squares here. Well, 5 is not a perfect square, is it? So that's why this one is prime. So again, why is this one prime? 5 is not a square. And here's another one that is prime. This one, a lot of times students do make a mistake on. Why would this one be prime? Well, 9 is a perfect square of 3, right? 25 is a perfect square of 5, but what do you notice in the middle? It needs to be a difference, and this is a sum. So this is prime because it must be negative in the middle. So that's why this one is also prime. Now let's look at the last part of this section. And so we're now going to look at what are called perfect square trinomials. So now we're going to look at our what are called perfect square trinomials here. And when we talk about perfect square trinomials, it's the same thing as what we've kind of done before, just a moment ago. When we looked at these squares, but it's got 3 terms. So let me find another sheet of paper here. Oh, here we go. So These are going to be perfect square trinomials. Here's what a perfect square trinomial looks like. And they're no more difficult than the last ones. Perfect square trinomials look like this. X squared. If it's a plus, it'll be positive, plus 2 xy plus y squared. That factors into x plus y quantity squared. Or x squared minus 2 xy plus y squared factors into x minus 2y quantity squared. Now the middle, we'll talk about that in a moment. But what we focus on when we look at these perfect square trinomials, again, think of tricycle, 3 wheels on a tricycle, 3 terms in trinomial. When we talk about trinomials, and these are perfect squares, we look at the ends. We look at the very first and the very end, and then we'll talk about the middle here in a moment. So let's look at a couple of these. And these are our perfect square trinomials. Let's use x to the 8th. Let's use a minus here. Let's use a 49 here. X to the 4th in the middle. Okay, let me just work this out. Make sure we get something that'll work here. 9 is a perfect square of 3, right? 49 is a perfect square of 7. We need a 42 in the middle. So why is this a perfect square trinomial? Well, when we talk about perfect square trinomials, we're going to focus primarily on the ends. It's similar to differences of squares, but it is a trinomial, so it has 3 terms. Well, let's talk about our x to the 8th. Okay, well, 9x to the 8th, that's going to be 3x to the 4th, all right, and 3x to the 4th, and we know that 49 is a perfect square of 7 and 7. What's the sign in the middle? Negative. So that's going to come down as a negative. And that's going to be 3x to the 4th and 7. Now, where does that 42 come into play? Well, the 42, if you look at your formula, we have the 2 in front. If we multiply these two together and double it, you should get the middle. 3 times 7 is 21. Double 21, what do you get? 42. All the ones that I give you are going to work this way. But if you had like a 50, it wouldn't work. Because you have to take these two, multiply them together, double it to get the middle. So it does work, right? 7 times 3 is 21. Double it makes 42. Let's do a couple more of these. How about we look at 25 y to the 8th. And we'll do a plus. Plus over here. How about we look at, let's say, 81. And we'll put the middle together. And let's make this 81 z to the 4th here. So we need a y to the 4th, z squared in the middle. And 5 times 9, double it, makes it 90. So how would this one factor? Well, what's the sign? Plus. So it comes down as a plus. And what do we know about 25? 25 y to the 8th is 5 y to the 4th, 5 y to the 4th, and 81 z to the 4th, well, that's 9z squared, and 9z squared, right? These are pretty simple. So what's it going to factor into? 5y to the fourth, 9z squared. How do we know that it works? 5 times 9 is 45. Double 45, what do you get? 90 in the middle. That's it. A lot of these are very, very easy to do. They're not complicated at all. You may also have to factor something out at the very beginning. So let's do x to the 10th, and let's put a 3 in front of here. And let's do a minus, let's do a plus over here. Let's do a 27. How about x squared on the end? And let's see, x to the fourth will be in the middle here, because that'll come out of there. And let's see, what else do we need here? How about we use a... Okay, that 3 will come out, so that'll leave you with a 9. So 6x to the fourth in the middle. Okay, so this is what we've got. Now, when we look at this at the very beginning, it's not going to work as a perfect square trinomial. Why not? Because this are not squares. But what can we factor out? Okay, these are all multiples of 3. So take out a 3, and then you'll take out a x squared, and that is then going to leave you with, now, when we factor that out, that's going to leave you with an x to the 8th, and then we have a minus. 3 comes out of there, so that leaves you with a 2. X to the 4th. 3 comes out of here. Right, well, yeah. Sorry about that. Just to make it work, make this a 9 in the middle. That way we're left with the correct. Let's see, is that going to work? Let me make sure. I may have made a mistake in the middle. Let me look at it again. Okay, so that'll come out. So that's going to be 3 times 2 times 3 again. Sorry about that. Make that an 18 in the middle. My mistake. That way it'll factor correctly. I just wasn't looking at it right here. So if we have an 18, we take a 3 out. So that leaves you then with a 6, which is what we want here. So 6x to the fourth here. Okay, and 27 divided by 3, that leaves you with a 9. The x goes away. Now it should factor out nicely. X to the 8th is x to the fourth and x to the fourth. So that means an x to the fourth is here. 9 is a perfect square of what? 9 is a perfect square of 3. And this should be a negative in the middle. Why is it going to be a negative? Because the middle here was what? Negative. Now, how can you check? 3 times 1, because there's always a 1 here, is 3. Double it, you get 6. This is a variable x to the fourth, and so is that. So we know then that we did it correctly. Now, we can also use this perfect square trinomial in conjunction with the difference of squares. So let's try to factor this one out. This one we're going to have to factor as a perfect square trinomial, and then we're going to have to factor it as a difference of squares. So let's look at one of these. We're going to have to factor it and factor it again. Okay, so how about we look at 5? Well, let's do 25. That's a perfect square. X squared. And then we'll do a plus, and let's do a plus here. How about we put a 1 here? And a 10x in the middle. And then let's do a minus 9z squared on the end. Now, how many terms does this have? Well, this has 4 terms, right? Okay, we need to factor by grouping. When we factor by grouping, we normally group the first 2 together and the last 2 together. But notice this one has a z squared. And it's the only one that has a z squared. There's nothing else to pair with it. And what we can do in this case with the 4 is instead of grouping the first 2 together, we can group the first 3 together. All right? Because if I group the first 3 together, this is a perfect square trinomial. Because 25 is a perfect square of what? 25 is a perfect square of 5. X squared is a perfect square of x. We bring down our plus here. And then 1 squared. 1's always a nice number because 1 squared is 1. 1 cubed is 1. 1's an easy number to work with, so that makes it a 1 there. And then we've got a minus z squared. 9z squared there. We are not done yet. Why not? We covered these earlier when we looked at differences of squares. This is a square. This is another square, right? So we can factor it again. So this can factor one more time as 5x plus 1, 5x plus 1. One of these is plus, one of these is minus. 9 is a perfect square of 3 and 3. Z squared is z and z. And that is it. Okay, so we factored it twice. Once as a perfect square trinomial, and once as a difference of squares. Let's look at one more of these, and then we'll move on to the next section, which is everything kind of combined together. So one more of these, and then we'll look at everything combined together. So let's try to factor out something like this. About 4 z squared plus 8 z x plus 4. How about x squared minus 64. Let's see, how about p squared? This is basically the same as question number 4. I just changed all the variables. But it is basically the same. All I did was I changed all the variables. Now, before we do anything else, no matter what the question is, before we begin factoring it as a difference of squares, a perfect square trinomial, factor by grouping, any of that, the first thing I always do is I look at all of these numbers together and I ask myself, what can I factor out? What can I factor out of here? What is in common? All these numbers are divisible by what number? 4. Okay? So the first thing I do before I do anything else is I need to see if there is a greatest common factor. Most of the time, there is not a greatest common factor, but in this case, there is. So I'm going to take out the greatest common factor, and so what can come out of all of this? A 4. And that then leaves me with z squared plus 2zx plus half of that leaves you with an x squared, and then 64. We'll divide that by 4. And that leaves you then with a 16 p squared. This one is by itself, and it's the only part that has the variable p on it. And I'm going to take this and factor this down here. And what's going to go here? Well, there's no number in front, so there's always a 1. Z squared can be split up into z and z. We have a plus, so that comes down as a plus here. The x squared is what? X, because x squared is x and x. X times z is xz. Double it, you get the 2. xz, right? Because 1 and 1 is 1. Double it makes 2. Can we go again? Yes, because this is a difference of squares again. So let's write this out as a difference of squares. And don't forget to bring down the 4. So the 4 just stays in front of it all. And this splits up into plus and minus z plus x, z plus x. And 16 is a perfect square of 4, so that's 4p and 4p there. And that is my final, finished, factored answer. So that now should cover all of 4.3. 4.3, we learned how to factor differences of squares. We learned how to also factor perfect square trinomials. Now let's look at 5.4, and 5.4 is a combination of everything. So 5.4 is everything we've learned, just all mixed up in a different order. So it might be factor by grouping. It might be factor trinomial, factor binomial, take out our greatest common factor. And this is 5.4. And this is everything we've learned so far, all mixed up. It's nothing new. All the same types of questions that we've seen before. It's just that now we have to put them all together. And we have to know how to proceed based upon the number of terms. So I'm going to give you different ones. We're going to go through all the different factoring techniques again. This one is very easy. I picked this one to be very easy because sometimes students try to make this more difficult than what it needs to be. So what do I do first? I look at this and I say, how many terms do I have? 2. Now it's not going to be a difference of squares because 8's not a perfect square. But I can factor something out of here. What can I factor out of here? The only thing that I can factor out is going to be a z, right? That's it. So take that z out, and that leaves you with a z minus 8. Now, here's where students sometimes try to make it more complicated. I cannot do anything else. How do I know when to stop? Okay, I took that z out. I cannot go any further because z minus 8 cannot be factored as a square, right? 8 is not a perfect square, and this z is not squared either. That's all we can do, was simply take it out. Sometimes students struggle with a question like this because it's too easy, and they try to do extra steps when they're not needed. Let's try another one, a different type to factor here. Let's see if we remember how to factor this one. Okay, let's come up with the middle. So let's say plus 38, because we have 9 times 8, that's 72. So you have 38, and we'll use 38 in the middle. How about xz squared? Okay, so we're going to try to factor this one. So what do we look at first? All right, well, when we have 3 terms, what are our options? Our options are perfect square trinomial, or we take this 3 terms and turn it into 4. Well, 9's a perfect square, but 8 is not a perfect square, is it? So that is not going to work for us. What's our other option? If it's not a perfect square trinomial, we look and we make sure nothing can factor out, and nothing can come out of this because 9 and 8 have nothing in common. And so it has 3 terms. So we covered these all in class last time. Nothing comes out. So what do? We take our first number times our last number. And 9 times that 8, well, that makes it a 72. Now, what's the sign of the 72? It's positive. So since this is positive, what do we know about the signs? They are the same. So they're either both positive or both negative. What's the sign in the middle? Positive. So that means these are positive. And what do we know about this? How's it going to factor? Most of the time, these would be very easy to factor. What do we know about 72? All right, 72 is a multiple of 2. It ends in at 2. It's an even number. So let's try 72 divided by 2. That's 36 and 2. Okay, what do we need? We need two numbers that multiply together to give you the 72 here, add together to give you 38. Well, that's pretty easy because 36 and 2 works, doesn't it? Because 36 times 2 is 72, and 36 plus 2 is 38 that matches here. So we know they both work. What do we then do? We then split it up. So we now have 9x squared. We have a 36x, z squared there. We have a 2xz squared. And we have an 8z to the 4th. So we split up that middle. And now what do we need to do from here? Well, from here, we now have it into 4 pieces, so we factor it by grouping. So I'm going to group the first 2 pieces together. And what can come out of here? Well, these both have a, let's see here, they both have a 9 in common, don't they? Right, so these have a 9 and an x in common. And that leaves you then with an x, and 36 divided by 9 should leave you with a 4, doesn't it? 36 divided by 9, that leaves you with that 4. I always double check things to make sure I don't make a mistake. So 4 is left over, and z squared. What about the next 2? Let's look at these. These have a 2 in common and a z squared. So 2z squared comes out. What's left over? X plus, okay, 8 divided by 2 is 4, matching, which it should. Z to the 4th, take out 2 of them, leaves you with a z squared. Are my groupings identical? Yes, they are. So that is now x plus 4, z squared. And what's left over? 9x plus 2z squared. And that's it. Let's do another. And we're just going to mix up all the different types. See if we remember how to factor out, let's say we look at this one. How about 5xs plus 3tx, and then let's do a minus 10. And let's use a, how about ps and a minus 6ts here. And if I did it correctly, this one should factor out nicely. And I think I did. Let me just double check. Yep, looks like that's going to give me that one there. Okay, so how do we factor this one? How many terms do we have? Always count the number of terms. We have 4 terms. No perfect squares, so I'm not going to try to group the first 3 together. What I'm going to do is group the first 2 together, because those have something in common. And what do they have in common? Well, these have an x in common. And that's going to then leave you with a 5s plus 3t. What about the next 2 pieces? These begin with a negative, so I'm going to factor in a negative. And what else? These have a 2 in common. And these also have an s in common. Or not, well, sorry, and that should be a p there. Make that a p. Sorry about that. I just put the wrong variable down. Make sure that's a TP there. That way it'll work. That was my mistake. I put the wrong variable down. Okay, these have a p in common, so that comes out. And that's going to then leave you with 10 divided by 2 is a 5. Negative and negative makes it positive. P came out, so it left you with an S. So that matches. Then we have a negative and a negative makes that a positive. 6 divided by 2, that leaves you with a 3. And the P came out, that leaves you with a 3 and a T there. Are my groupings identical? Yes, they are. Right, those are identical, so those can come out as a 5S plus 3T. What's left over? Gone and gone here. X minus 2P. Let's do another one. Let's see what we can do with this one. How about 392 z to the 12th power minus 200 x to the 9th power. The first thing we do is we check for squares. Now, sometimes you may have a really large number, okay, but that 392, if you use your square root key, see, that's not a perfect square, is it? 200 is not a perfect square either. But what can we factor out of here? Well, these have what in common? Okay, I think they have a 2 in common. They have a 4 in common. And I think we may even be able to take out an 8. Because these all have an 8 in common. Now, how do I know I'm doing this correctly? Well, let's take that 392 and let's divide that by 8, because these both have an 8 in them. And what does that leave you with? Okay, that leaves you with a 49 z to the 12th. And what's special about 49? That's a perfect square, right? So that's what we want. What about the 200? Well, if I do 200 and I divide it by 8, what do I get? 25. All right, so that's going to be 25x to the 9th. Now, why is that also important? Because 25 is another what? Square. So how does this factor from here? The 8 stays. We have a plus and we have a minus. 49 is a perfect square of 7 and 7. Z to the 6th. Z to the 6th. And then what about 25? 5 and 5, x cubed, x to, I should have made this x, make this next to the 10th there. That way it'll work. Otherwise it won't. Sorry about that, wasn't careful. Make that an x to the 10th there. And then that way that'll split up into x to the 5th and x to the 5th. So that should be an x to the 10th there. Let's do a couple more. We've got a few more minutes here. Let's do at least 2, maybe 3 more, just to make sure, again, we review all of our different types of factoring. This is everything just kind of mixed up together. Okay, let's look at this one. How about we look at 25 x to the 4th times z plus 9. And then let's do a minus 9 times z plus 9. Okay, now I picked this one because we're going to have to do 2 steps here. And the first thing I always do is I look to see if we have either a variable or a combination of variables that are the same. In this case, we have our parentheses, right? These are numbers and variables, and they are the same. So I can take out a z plus 9. And what's going to be left over? 25x to the 4th minus 9. Now, we are not completely done yet. Why are we not completely done? Well, we are not completely done because what about 25 and that 9? Those are perfect squares, right? It's got a negative in the middle, so it's a difference. So this can go again. Now the z plus 9 comes down. It's done. But the 25 is a perfect square of 5 and 5. And x to the 4th can be split up into x squared and x squared. And we have a plus and a minus. And 9 is a perfect square of 3 and 3. And so that's it. This is our final, finished, fully factored answer. Let's do at least one more. How about I give you another one here, and I'll just make up one real quick here. Let's make sure we remember how to factor this one out. How about 49 x to the 8th times a minus b quantity squared. And we'll do a minus, and we'll do a plus over here. How about a minus b quantity squared here? And let's do a 14 x to the 4th a minus b quantity squared here. Okay, now this one looks really intimidating, but it's actually very, very easy. First thing I always do is I look at this as a whole. And what do they have in common? Well, they've got parentheses that are the same. All right, so let's take out that a minus b quantity squared. So that's going to come out. And if I take that out, and you can use brackets if you want, if there's too many parentheses, which I think I will in this case, that's going to then leave you with a 49x to the 8th, because that came out. And then we've got a minus 14x to the 4th. And here's something that I want to make sure that we're all aware of. If this completely came out, it's completely gone, what do we leave? We leave a 1. So when anything comes out completely, you always leave that placeholder of 1. Very, very important. Now, what do we know about 49? Perfect square of 7. What do we know about 1? Perfect square. So, how is this going to factor? What's the sign in the middle? Minus. It comes down. And we know 49 is a perfect square of 7. X to the 8 splits up in half as x to the 4th. And we know 1 squared is 1. What is still out in front of it? A minus b quantity squared. Okay, let's see how much time we have left. We'll probably do 2 more of these just because we can't get enough of factoring. Very, very important that you can factor. You have to be able to factor. So we'll do 2 more. So I'll do 1 more, and then I'll pass out the sign-in sheet here. So let's do a more complicated one. How about we look at 16 x to the 9th minus, and we'll do a minus over here. How about we do a 7 here? Okay, and a 32. Let's make it x to the, let's see, we need an x to the 4th, sorry, x to the 5th here. That way that'll come out correctly. and we need an x here. All right, so the first thing I would want to do is I want to see what we can factor out, what's in common. And there may or may not be anything. Make sure I did it correctly. Make sure it factored. Let's make this a plus. That way it'll work correctly. We want to make sure it works out the way it needs to work out. Okay, so nothing comes out because 16 has nothing in common with that 7. 16 is a perfect square, but 7 is not. So it's not a perfect square trinomial. But they can factor out that variable x. So that's all you can do. And that leaves you then with a 16 x to the 8th minus 32 x to the 4th. And then we have a 7. Nothing comes out. First times the last. 16 times 7. Well, 16 times 7 is 112. We need the two numbers to give us 32. Now, this is positive here, right? So that means they are the same. And what's the sign in the middle? Negative. So that means these are both negatives. Now, 112 is an even number. So that means we're going to try multiples of 2 and 4 and 6 until we eventually find it. Sometimes it's a lot easier to find than others. So let's start with 112 and let's divide it by 2. 2 and 56. Does that give you 32 when you add them together? No. Okay. What about 112? Let's divide that by 4 because that's our next even number. Well, that's 4 and 28. 4 plus 28 is what? 32. So what are my two numbers? 28 and 4. Because those go together when we multiply minus 28 and minus 4. Well, that gives you 112. And minus 28 minus 4, those go together to give you that minus 32 in the middle. So see how everything matches up. Now we split this up, factor it by grouping. So we have a 16 x to the 8th. We have a minus 28 x to the 4th. We have a minus 4 x to the 4th and a plus 7. Well, you can go a little bit further here because these have what in common. Okay, now what I'm going to do to make it easier on myself, to make sure I factor it correctly, let's do the last one first. 4 and 7, they have nothing in common. But it does have a negative, so I'm going to go ahead and factor out a minus 1. And that's going to leave you then with a 4x to the 4th minus 7. So that means when I factor out the first two pieces, I need to have a 7 here. And what about 28? Well, 28 divided by 7, 28 divided by 7 is a 4. So I'm going to take out a 4 and an x to the 4th. And 16 divided by 4, that makes it a 4. X to the 8th, take out 4 of them. That leaves you with an x to the 4th. See how they're matching so far. So everything looks right there. And then we have our minus 28. And minus 28 divided by that 4, well, that's a minus 7. And the x to the 4th comes out. Now, are my groupings exactly the same? Yes, they are exactly the same. So that comes out in front. And that's a 4x to the 4th minus 7. Gone and gone. And what's left over? 4x to the 4th minus 1. A lot of times, students may think we're done, but we are not completely done here. Why are we not completely finished and done? Well, the first one has a 4 and a 7. Those are not perfect squares, are they? But what about the next one? This one can go again, because 4 is a perfect square of 2, and 1 is a perfect square of itself. X to the 4th can split up. So this is an additional difference of squares. 4 squared is 2. Or sorry, 2 squared is 4, I mean. So we need a 2 and a 2. X to the 4th splits up into x squared and x squared. We have a plus, we have a minus, and 1 is a perfect square of itself. So that is as far as we can possibly go. So we had to factor, and then we had to factor it again. This does not happen very often. Most of the time, all you have to do is factor it once. This is a unique case because it could be factored again, because this is an additional difference of squares. Now, how do I know when I'm done? A lot of times students struggle with, when am I done? 4 and 7, nothing in common. 7 is not a perfect square, can't go any further. 2 and 1, well, 2 is not a perfect square, can't go any further, nothing's in common. Same thing here. That's as far as you can possibly go. I think we have enough time to probably do one more. And so I'll go ahead and pass out the sign-in sheet. So let's look at one more. And let's try to factor this one out. Make it fairly simple. About 9. How about z to the 12th minus, let's say, 81 x to the 10th. So this one's fairly easy. It's our last one. We'll make it easy. Now, we could factor it as a difference of squares at the very beginning, but if we did that, we'd have to factor it again at the end. So before we factor it as a difference of squares, we look at this in total, thank you, and we have a 9 and an 81. Well, they are squares, but 9 and 81, well, they have a 9 in common. So let's take out that 9 first. If you don't take it out at the beginning, you're going to have to take it out at the end. And it's easier to take it out at the beginning. And so if I take a 9 out of there, then that leaves you with z to the 12th minus 9 x to the 10th. And now we know we can go again because 12 is divisible by 2 for our powers, and 10 is also divisible by 2. And we know that 9 is a perfect square again of 3. 1 is plus and 1 is minus. So z to the 12th splits up into z to the 6th, z to the 6th. 9 splits up into 3 and 3. X to the 10th splits up into x to the 5th and x to the 5th. And that is as far as you can go. Now, how do I know again I can stop? These can't go any further because 3 is not a perfect square. Therefore, we know we are done, and that's all you can do. So what's going to be your homework? Let's talk about that quickly here. So the homework is going to be 5.3, we did them all. 5.4, we did them all. Our next exam is going to be on Thursday. So Tuesday is going to be review. Tuesday we'll come in, we'll break into groups, or if there's not enough students, we'll just do one big group, and you work together on that practice exam. Okay? And so just so everyone knows, this will be our last exam before the final. So we'll have an exam over that multiplication, rules of exponents, and factoring. And then we'll start getting ready for our final exam, which will have the quadratic formula will be in there on the final. We'll do factoring. It'll be everything. We'll also look at rational expressions. So that's what we're going to be doing, and that's our agenda. is exam's going to be on next Thursday, so a week from today, and we'll be reviewing on Tuesday. And we're almost done with the semester. So only, I think, 6 weeks left, so not that much left.